Welcome to ETM 260 Computer Aided Design. This is lecture 4, Editing, Extruding, and Revolving Sketches. This video is supplemented with a given PowerPoint. We will go over some of the techniques that can be used to edit sketches. Let's just start with Quick Trim. To show you how it works, we're gonna open the given file. Open lecture 4, part 1. Quick Trim is a tool that can be used to cut and remove unnecessary curves from the sketch. To show you how it works, we're gonna double click on the sketch and we would like to remove these curves. To do so, go to the Direct the Sketch toolbar and select Quick Trim tool. We're gonna remove the curves simply by clicking on it, or you could drag your mouse and create a path, and as you do so, the curves will be removed. To show you other two tools, we're gonna open the file name Lecture 4, Part 2. We're gonna learn how to create a corner and how to extend a curve. Let's open the sketch. The first tool we're gonna do is Quick Extend, which allows you to increase the size of a curve until it reaches a boundary. We're gonna extend this line until it reaches this line over here. To do so, go to the Direct the Sketch toolbar and select Quick Extend. You're gonna put your mouse in top of the line and notice how it extends until it reaches the boundary. Once you're done with your selection, simply press in the mouse key. To create a corner, it simply takes two lines and it creates a corner wherever they will intercept. To do so, go to the Direct the Sketch toolbar and make a corner. Select the two lines that you would like to use and notice how a corner is created. The next tool that we're gonna show is the Offset curve. To show how it works, we're gonna open the next file, Lecture 4, Part 3, and we're gonna open the sketch. Notice that these two sketches are quite similar. The main difference is that the upper sketch is a closed path. Notice that it has coincident points in every single one of the corners. However, the bottom one is an open path since it's missing this particular coincident point. In order to offset a curve, we're gonna go to the Direct Sketch toolbar and we're gonna select the offset icon. We need to select a curve. When we do the selection, we have different methods to select it. We go to this part and we could either select single curves, connected curves, tangent curves, or curves in a group. Let's just start with single curves. You select the curve and notice that you have a distance for the offset. In this particular instance, the offset is going into the part. If you would like to change the direction, simply click on this icon. Notice that at this moment, we only have one particular copy of the offset. If you want more copies, simply increase the number. The offset distance between the features, it will be exactly the same. In the same way, you could create symmetric offset, meaning that it will go in both directions, as is shown. Let's undo this so that I could show you how to do an offset of a closed path. We're gonna once again do offset, and then instead of selecting single curve, we're gonna select connected curves. We're gonna change it back to non-symmetric and only one. The difference when you have connected curves is that you select one single one, and if the geometrical constraints are properly done, then every single curve connected will be selected. This is a great advantage when you want to duplicate the geometry and you don't have to do step by step. We could change the offset distance, let's see, to 5. And once again, you could either add the number of copies that you would like to have, and also to make it symmetrical. Let's now see how it works with an open path. We're gonna go to the offset tool again, and we're gonna have connected curves. Once again, we do this. Notice, however, that in this part, so to see it better, we're gonna remove the number of copies and the symmetry. Now notice that in this particular curve, because it was not coincident, the path is open in this point. So it is very important that you double check what is the goal that you want. If you want this to be an open path or a closed path offset, you need to be able to have your geometrical constraints properly defined in order to meet your requirements. The next tool that we're going to learn is how to mirror a curve. We're going to use the same file used previously. Mirror a curve is a tool that allows us to duplicate one or more curves about a given axis of symmetry. To know how to use it, we're going to go to the Direct Sketch toolbar and we're going to select Mirror the Curve icon. We're going to mirror the upper sketch using Connected Curves. We select the curves and then we select the center line. To do the center line, we're going to use this axis over here. And notice how we mirror the features. If we want to do is simply mirror about the other side, and we want to use this line as the axis of symmetry, we need to do the following. Go to the mirror the icon and select the curves. Now we're going to simply do single curves instead. The reason we do this is because we want to make sure that we do not select this line, because that one will not be duplicated. It will be used as the center line. Once we have selected the curves, we're going to select the center line, and then we're gonna do that selection. The next tool we're gonna use is to learn how to create patterns. To do so, open the file, Lecture 4, Part 4, and open the sketch. What we want to be able to do is create a pattern, which is a very useful tool to create multiple duplicates of one or more curves following a given pattern. What we want is to take the circle and we're gonna have it repeated in one direction, and then we're gonna have it repeated in a secondary direction. To do so, go to the Direct Sketch toolbar and select the Pattern tool. The first thing that we're going to do is select the curve that we would like to pattern. Notice that we have different choices of the patterns. We have linear, circular, and general. We're gonna go first over linear. We're gonna select the direction that we want the pattern to follow. We're gonna choose the horizontal direction, so you could choose either a line or the axis. And at this moment, you have different ways of doing the spacing. You could either have the count and the pitch, meaning how many duplicates you want and what is the distance between them. You have count and span, you know the number of instances and the total distance that they will occupy, or pitch and span, which is the distance between them and the total distance that it will occupy. Let's see now that we want 5 and we want a distance of 10 between them. Notice that if you want, you could also change the direction that you would like to use, to one side or reverse it, and click OK. If we want to edit this pattern and make it a two-dimensional pattern, we could follow this process. Notice that you have 3 dotted lines over here which indicate a pattern. Double click on it and it will open the menu that we had previously. If we want to do 2 directions, simply click on this box. Let's choose the second direction, which we're gonna use this line, or once again the axis. and we're gonna revert the direction so that it's actually inside of the sketch. Once again, you have the same choices. Let's do it 3, and so on and so forth. Let's reduce the size a little bit so that it fits within the box. And once you are done with the information that you want to put, simply click OK. Let's now learn how to make circular patterns. To do so, open the file, Lecture 4, Part 5, and open the sketch. Go to the Direct Sketch toolbar and select Pattern. In this case, we're going to select the circular layout. We're going to select the little circle to be the curve that we would like to pattern, and we would like to choose the center of the big circle to be the point by which the pattern is going to be done about. We have the same choices for the spacing as for the linear case: count and pitch, count and span, and pitch and span. We're going to select count and span. We're going to have 15 little circles going about the whole circle. So we put 360 degrees. Once you are happy with your selection, simply click OK. If at any point you would like to change any of the patterns, notice that you're going to have a little symbol for the pattern. You could simply double click on it, and you could go back, change the selections, and it will regenerate. The next tools we will learn are how to copy, to move, and to rotate sketches. These are very useful when you want to modify the position, the orientation, and the number of curves in a sketch. Let's go to the Tools toolbar. Select Move Object, and we're going to select the curves that we would like to modify. Make sure that you only select curves. Do not select dimensions, Danton planes, or Danton axes. Also, it is important to know that when you are moving an object, it cannot conflict with any geometrical constraints that you have imposed before. We want to move, make sure that this is clicked, and we're gonna move, let's see now, in the x-axis, in the y-axis only. So you simply move. If you select the axis, this indicates that it would only move up or down. Click OK. Now let's do the selection again. So once again, just the curves. And notice that we could select before we choose the command. Move. Move. This one is missing. Select now. And we're going to move in the x-axis only. If you want an orientation, that translation that is not only in the x or y axis, you could just simply move randomly to the position that you desire. If you want to copy, follow the same process. The only difference is that now you're going to be able to click where it says Copy Original. Click here, and now it gives you the number of copies that you would create. Follow exactly the same process, and now you're gonna see that 2 different copies are done. If we want to rotate and sketch a particular curve, we need to do the following. Select Move Object, and let's see, we're gonna rotate all these features. You have to make sure that the coordinate system is in the position that you want to rotate about. We want to follow in the same process if you want to just move or copy. So let's see, now we're just going to move, and we want to rotate. The difference is now that we do not select an axis, but we select a position to rotate by. Notice that we could just select the value that we want to rotate by. We could either do it randomly like this, or you could enter the value and the angle and the snap. Once you have selected your new position, click OK. Once a two-dimensional sketch is complete and fully constrained, the user might want to transform it into a three-dimensional solid. The most common methods are extrusion and revolving. Let's start with extrusion. To do so, open the file Lecture 4, Part 6. Extrusion is a method in which the material is added perpendicular to the sketch. This particular sketch is done in the top view. You could see that by having it in the isometric view. If we want to add material, it's going to be added going up or going down perpendicular from the sketch. We're going to double check that the sketch is fully constrained to ensure that we could extrude it properly. Once we double check that, we're going to finish the sketch. I'll always recommend, before you do any revolution or extrusion, to have the sketch in an isometric view to ensure that you add material in the direction that you want to. Now let's go to extrude. And we're going to have different choices of how we are going to extrude. The choices are going to be given by this filtering over here. If you want to only extrude the outside curve, you could either do single curve or connected curves. I recommend to use connected curves to ensure that all the constraints are properly done between the curves. Notice that if we select one, all of them will be created. Once again, if we do only by connected curves, a box will be created and extruded. Let's go over the different methods that you could have over here. The direction indicates whether you're adding material going up or whether you add material going down from the sketch. The limits, you could do it by giving them a value. When you start at a distance 0, it means that you start right flushed from the sketch. And then you provide a distance offset from where you start. You don't necessarily have to have 0. For example, you could say I could start at 10 and finish at 35. Notice now that the extrusion has a distance away from the sketch. You could go back and change the values depending of what the solid looks like. The other choices that you have when doing an extrusion are the following. Expand the menu, and let's start with draft. Draft indicates that there is going to be an angle that you're going to have when extruding. Notice that you have start to limit, and you have an angle in which it reduces the extrusion as it goes up into add material. Let's do 15. And notice how it's been drafted. You could do it on a specific section if you want to. Or you could do a never negative angle to indicate that you want in the opposite direction. To continue with the other choices, let's remove the draft. Let's go into offset. Offset indicates that the extrusion is going to be created at a distance from the given sketch. Let's see, we have single-sided. Notice that we have a distance between the actual extrusion and the sketch, and you could change that particular distance. This is single-sided, means that it only goes to a particular side of where you want to be. If you go two-sided, notice that it provides basically kind of like a shell around the sketch that you want. It also gives you the ability of doing symmetry, which means that it indicates that it's going to be 10 to one side and 10 to the other. Let's now remove the offset to show other choices of selecting the curves. Let's say you didn't want to have only the outside curve, but you wanted to add the circles that were added into it. You have a couple of different choices. Either you select the outside curve and the inner circles like this. And notice what it's doing is simply taking the region inside of the selected curves, and you will create the extrusion based on the information that you provide. That is one way. The other way is doing this. To show you how it's done, I'm going to hide this extrusion for a second. Notice I'm going to just simply unclick here. And as I said before, it does not delete it, it simply hides it or deselects it. So I'm going to do extrusion. And then instead of selecting connected curves, I'm going to just have region boundary curves. What that allows you to do is select the region that you would like to have without having to select every single one of the curves. Then you provide the information that you want and then click OK. Any of those two methods will work. Let's now learn how to use the Boolean functions when creating an extrusion. To do so, open lecture 4, part 8. In this particular model, we have one extrusion that it was created using the first sketch, and then we have a sketch that it was created in the upper surface of that cylinder. What we would like to do now is extrude this particular sketch using different Boolean techniques. We're gonna go to extrusion, we're gonna select the curve, we're gonna do connected curves, select the curve. Notice that in this case is going to give us an extrusion going perpendicularly up from the surface. Just gonna make it a 10. And the first Boolean technique that we're going to use is going to be unite. What it's going to do is going to have this solid joint to the bottom solid. Let's learn another technique. For now, let's just deactivate that extrusion and try it again. Let's do extrusion. Once again, let's select the curves. And we're going to go in the opposite direction. And what we are going to do instead of unite, what we're going to do is subtract. Meaning that it's going to remove that particular region from the original cylinder. At this moment, we have the choices of going to a specific value. Let's see, only 2. And we could preview it by using this. So notice that it goes simply that amount of a distance. If we want to make sure that it goes through, instead of using value, we're gonna choose through all. This ensures that the hole goes throughout all the material. We're going to learn the other techniques that we have for the limits in the next lecture. Let's hide this extrusion so we can learn the third possibility. We're going to do extrusion. We're going to once again connect the curves. And instead of selecting subtraction, we're going to do intercept. Notice that what it's doing is simply selecting the quantity that is going to be intercepting between those two sections, and it's going to create the feature. Let's now learn how to do a revolution. To do that, open the file, lecture 4, part 9, and notice that we have this as sketch. A revolution, it simply creates a solid by revolving a material around a given axis. To access revolution, simply click in the arrow underneath extrude and go into revolve. You're gonna select the curves. The best method is to do connect the curves, select the curves. At this moment, you need to select an axis for rotation and a point to rotate by. We're going to select the axis, the z-axis, to rotate about. Notice how the rotation is done. You have basically the same choices for limits as you had in extrusion. You could start at 0, and let's see, if you only want to have half a revolution, you simply do up to 180 degrees. Once again, you have the same choices for Boolean, unite, subtract, and intersect. Let's see how important it is to select the proper axis. Notice how this feature is currently by using that particular sketch. We're going to hide it for a second and do the process all over again. Select Revolve again. Let's select the curves. And now we're going to revolve about this line over here. We're going to specify the vector by selecting the 2 points in the line. Notice how the rotation is completely different. To see it better, we're going to change the orientation of the rotation by changing the axis of the vector. So now we could see the feature much better. So please notice that when you are doing a revolution, it's not only important to have a proper sketch, but to properly select the axis that you're going to do the revolution about. Once the solid is complete, the user has the choice of hiding or showing some of the features. It is always recommended to do this before saving a solid. First, make sure that it's in the isometric view. Second, click on the hide and show icon. It is recommended that you hide the sketches so it doesn't look as busy. And depending on the features that you want, you might want to hide the coordinate systems. This is completely up to the user. It is recommended so it doesn't look as busy. This is the end of lecture 4, editing, extruding, and revolving sketches. Please make sure to complete all the required quizzes, review the materials in the given PowerPoint and chapter 4 from your textbook, and be ready to start class assignments.